Hi everyone, in this video we're going to talk about how to find the constant in an indefinite integral by using a boundary condition. Let's do it. So we know that the integral of f prime of x is equal to f of x plus a constant c, because of course f is the antiderivative of f prime. But how can we figure out what c is? Okay, so we're going to call lowercase f of x plus c uppercase f of x. Okay, so we're going to name this expression lowercase f of x plus c, we're going to name it uppercase f of x. And we're given the following boundary condition. We know that f uppercase f of a is equal to b. And a and b are constants, they're numbers. So if we replace a into the expression above, we're going to have lowercase f of a plus c equals uppercase f of a. We can then isolate the constant c. And finally we can replace uppercase f of a with b from our boundary condition, and now we have an expression for the constant c. Okay, but this is only a general case. Let's take a look at an example to see how it actually works. Okay, in this example we have the integral of 3x squared plus 2x, and we know by finding the antiderivatives that is going to be equal to x to the power of 3 plus x to the power of 2 plus a constant c. Okay, and what we're going to try to do is to figure out what is the constant in this function. Notice the problem tells us that f of 2 is equal to -3, so we can replace that into our expression by plugging in the 2 for x and then setting that equal to -3. And now we can apply some algebra here to combine like terms and isolate the letter c. And we get a final answer of c is -15. So our integral is going to be x cubed plus x squared minus 15. Alright, now let's take a look at another example. We have the integral of 1 over the fifth root of x cubed. And the first thing is that we can rewrite this expression to make it something that we can integrate a bit more easier by writing it as an exponent with a negative because it's in the bottom. Okay, and then we can apply the power rule. Okay, so now we can apply the boundary condition. Okay, the problem tells us that the graph passes through the point 32, 30. And what that means is that f of 32 is equal to 30. So we can plug in 32 for x and set it equal to 30. And then we can isolate the constant c. Okay, now let's take a look at this last question. I'm going to read it. The rate of growth of a population of fish is given by the derivative of p with respect to t equals 150 square root of t for t between 0 and 5 years. The initial population was 200 fish find the number of fish at t equals 4 years. So there's a lot of things to solve this problem, but what I really want to focus on is to identify the boundary condition. In this case, notice that it says that the initial population was 200 fish. Okay, and this is really my boundary condition. What that means is that the function p of the population, when you evaluate it at 0, which is the initial time, is going to be equal to 200. Alright, so that is the boundary condition. P of 0 equals 200. Okay, and now we can go and solve the rest of the problem by finding the antiderivative. We're going to apply a power rule again. And then we're going to, once we have the expression for the antiderivative, then we can apply the boundary condition by replacing the time with 0 and the population with 200. And then we can isolate the constant, so which is going to be pretty easy in this case. C equals 200. So my final expression for the population is 100t to the power of 3 over 2 plus 200. Now when the time is 4 years, all I have to do is replace in my population function t equals 4, and that's going to give me my final answer, which in this case is going to be 1000 fish. Alright guys, that's it for this video. Thank you for watching. Until next time.